Okay, so last time we started reading about line drawing algorithms, and we discussed the first one, which was DDA, Digital Differential Analyzer Algorithm. Okay, we are going to repeat that quickly, and after that I'm going to discuss the Bresenham algorithm, and we are going to compare the two and how do they work. And remember that you will have an assignment in this chapter or in the line drawing algorithm. Okay, so pay attention, and if you have any question you can ask me question about the any of the algorithms. Okay, so the first algorithm, a digital differential analyzer. Okay, we will see that what is that. It is analyzing the difference between the slope of the lines. Okay, and we are going to consider some conditions for how the slope of the line changes and how we draw a line. Okay, so we start with the line equation. We know that a line equation uh, is y is equal to mx plus b. M is the slope, and we find the slope by using 2 points, any 2 points on this line, take anywhere, and the difference between their y coordinates, y2 minus 1 minus y1, and the x coordinates, which is x2 minus x1. So this difference gives you the slope of the line. Okay, so actually it tells you what is y2 minus y1. It is difference between the height, okay, of 2 points. So if this is my y2 and this is my y1, so this difference is the top, y2 minus y1, and the horizontal difference between the 2 points actually is the denominator. Okay, so if this difference is high, okay, or first let's say if they are same, y2 minus y1 and x2 minus x1, if they are same, so the answer will be 1, which will give us the slope of 1. Now if y2 minus y1 is more, it means that the line will be going up. Okay, like in this case, this difference is more than the horizontal difference, so the line tends to go up, and this gives us the slope of greater than 1. But if y2 minus y1 is less than x2 minus x1, so the gap between the horizontal points will be more and the vertical coordinates will be less. So the line will be like more towards horizontal and not towards the vertical. Now there is also the b value, which is known as the y-intercept. What is b? B actually tells us about the point where this line, okay, will touch the y. Okay, so it's somewhere here. In the diagram it's here, but this is wrong. Okay, actually not, this is not b. B is actually y-intercept, which should be here. Okay, so for these calculations we will consider b to be 0. And what does b mean to be 0? B means b is equal to 0 means that the line will be passing through the origin. Okay, so when x is 0, y will be 0. So all the lines that we discuss here, they will be passing through the origin, whether in this direction or that direction, whatever, but it will be passing through the origin. So here is an example of a line in which m is equal to 1, which means that 45 degree. Why? Because this distance between x2 and x1, this is the same as the difference between y2 and minus 1. That gives us m is equal to 1, which is a perfect line between 45-degree angle between x and y degree. Then we have four different conditions. Although we have only two possibilities, m is less than 1 and m is greater than 1, but we also consider another thing, that if we draw a line, do we start from left to right or from right to left? Left to right means that we consider the left point as the starting point and the right ending point as the end point. So we start a line from the left going towards the right. That is left to right. Okay. And other option is right to left. So we take this point and we start from here and go until the left point. Okay, so how do we find the left and the right? The point from which we start, we will see if it is less than the other point, the x-axis, or if this one is greater than the left hand side. Okay, so that is the difference. Now in general, here we see that m is less than 1. When will be m less than 1? Actually when the line is below the slope, and this will happen if x2 minus x1 is greater than y2 minus y1. Okay, so m will be less than 1, and the line will be somewhere here. It can be anywhere below this m is equal to 1 line. Okay, now in this case we start with delta x is equal to 1. What is delta x is equal to 1? It means that we will change x by 1 only. Okay, so we are starting from left to right. Our left point is, for example, here from 0 0. We start from here and we change x by 1 every time. So if we start from x is equal to 0, then x is equal to 1, x is equal to 2, and so on. This will continue like that. So this will be on x-axis. But we change y not by 1, we change y by m, which is the slope. Okay, so this small change in y, why do I call it small change? Because it is less than 1. So this change will lead to actually either selecting a pixel which is above or the pixel which is the same. Okay, so yk plus 1, it may be same as yk if the difference is small, or it may be one more than yk if it changes the integer. We will see this example. Okay, so this is the basic principle. Okay, the condition is if m is less than 1 and we are moving from left to right. So the change in x will be 1 from left to right, and the change in y will be m, okay, which is here. Okay, then we use a for loop. Now remember, try to understand this for loop. In this for loop, we are considering how many points? We are considering points from 0 to x2 minus x1. What is x2 minus x1? x2 is this, x1 is this. So these points. So we start from 0, but total number of iterations in the loop, it will be from here to here. So let's say these are 10 points or 20 points. It depends, but we will run this loop only for these number of points. Okay, and it will, although this starts from 0, but this is just for counting. Okay, this is for counting. Okay, we don't count starting from this 0, but actually this 0 means that we are counting from here until here, and from 0 to whatever is the difference between these two. So it will cover actually this area from left to right. Now we say delta x is equal to 1. So for every iteration, x next will be x past plus 1. Okay, so xk plus 1 is equal to x of k plus 1. This is the next x. And what is y? Yk is equal to yk. Yk plus 1 is equal to yk plus m. So these two are there in the loop. And then we will plot the next x and the next y which we calculate here. Very simple. Okay, so that is one condition. What will be the next condition? The next condition we can consider that m is less than 1, but we start from this point, right side, and we go to left. So what will be there? We will be decreasing x. So the difference will be that you see we are decreasing here, and the thing will be that we will decrease the x by 1. Okay, so delta x will be 1, but it will be actually minus 1, we can say. Delta x will be minus 1. Every time it will be decreasing by 1, and yk will be decreased by minus m. Okay, so that is the second condition. Delta x is equal to minus 1 and yk is decreased by m. The remaining loop, it remains the same, and we will plot it. So very small change. We just replace the positive by the negative when moving from right to left. That is the second condition. Okay. Now the third condition is when m is greater than 1 and moving from left to right. Now here is this line. Okay, it is above this line, which is m is equal to 1. So we are in this region anywhere. Okay. Now you see we are considering delta y is equal to 1. Here we are going to change y. Okay, and the x change will be 1 over m. Okay, the change in x will be 1 over m, not m, and because we are moving left to right, so x is increasing and y is increasing, okay, in this direction. Now remember that there is one problem because we are making delta y is equal to 1. So this thing here, this is y2 minus y1. Okay, this is wrong actually. Okay, this thing here, this should be y2 minus y1. So y2 minus y1. Okay, let me make it clear. So there is one problem. I will show you the code. Why is it that? Okay, so we are moving from this point to that point up, and y is increasing by 1 always, and x is increasing by 1 over m. Okay, small change in x, and we will plot the same thing. The last condition is about okay, here is the font size. Yeah, so this is y2 minus y1, and the same y2 minus y1, it will come in the next one also. Okay, so what's the next one? The next one is the fourth condition, which is m is greater than 1, same line, but this time we start from right to left. Okay, so when we go from right to left, so delta y will be minus 1. We will start drawing from here, and delta x will be actually the change from xk minus 1 over. So just like the second condition, the fourth condition will only change this to minus, and here once again it will be the same thing, that is y2 minus y1, not x2 minus x1. Okay, so we should be careful about this thing. Okay, so these are the four conditions. Now let me show you the code and the actual analysis. How does it work? So here a small code I have written, and I will show that to you. Okay. Oh, I lost it. Wait. Just give me a minute. My mistake. Okay, so here is the code. We learn from here. Okay, so here is the code which will draw a line. It will draw a line on the context. Okay, and x1, y1, x2, y2, they are the 4 points. Okay, so these x1, x2, x1, x2 is a starting point, x1, y1, and x2, y2 is the end point. Okay, so we have 2 points with coordinates x1, y1 and x2, y2. So we start from x1, y1. Okay, we will use this. First we find the slope. What is the value of slope? Slope is equal to y2 minus y1 divided by x2 minus x1, and we say that b is equal to 0. We can change b, that's not a problem. We can have any value for b, and we will be able to see that. And then this is just to print the message on console. So m is equal to m, it will print the m, and b is equal to b, it will print the value of b. So b is always 0 in this case. If we change, okay, that will be different, but normally it will just print the m value. Okay, and then we have 4 conditions. Condition 1, when m is less than 1, and this is and x1 is less than or equal to x2. Now I'm considering less than or equal to, because if it is less than and the other one is greater than, then we cannot check for this condition. So we need to have a condition for equal to as well. Okay, so this is the first condition. M1 is m is less than 1 and x1 is less than or equal to m2, and this is also here in the the summary of 4 conditions. The first condition is this one: m is less than 1, and we are moving left to right, which means left to right means x1 is less than x2. That is actually x1 is less than x2. Okay, and right to left means what? Right to left means x2 is less than x1, or x1 is greater than x2. I can write it like this: x1 is greater than x2. Okay, so we are on the right side. So that is the conditions. First condition, m is less than 1, x1 is less than x2. So what do? We will do is that xk plus 1 and yk plus m. Okay, these are the 2 things. X is 1 and y will be added by m. So here x is equal to x plus 1, y is equal to y plus m. And then we will print a point. So this is a point. Why? Because it is 1, 1. So this is still right, but its width and height will be only 1, 1. So it will print it. Now here I have added b. Okay, but b is 0. So it will not do anything. It will just print x and y position. So here we find the x and y position. Now remember that when we start, we have the very first point. We will print that as well. So I am updating my x and y. I start with x1, y1, and I am updating my x and y. Okay, so this is next x and this is next y, and then I print it on the screen, and then this loop will continue. For how long it will continue? It will continue x2 minus x1. What is x2 minus x1? You can see. Okay, we will see that the values of x2 minus x1. So it's the difference between 2 points. So if this is 20 and this is 10, so this will be 20 minus 10, which means 10. So this loop will go for 10 times. Okay, it will go for 10 times. Okay, that's the condition 1. The condition 2, m is less than 1 and x1 is greater than x2. Okay, the difference is x1 is now greater than x2 in condition 2, and you remember when we greater than x2 means we are from right to left. Okay, it means from the right to left, and this one, the first one, condition 1, is here. Okay, which means from left to right. Okay, so when we have right to left, what we do is we will change this. Instead of x2 minus x1, we will make it x1 minus x2, because x1 is greater than x2 now. Okay, and before, when we are doing left to right, we do what? We are doing x is equal to x plus 1. But when we move from right to left, we will say x is equal to x minus 1 and y is equal to y minus m. Okay, and we will draw the same point once again. This is condition 2. In condition 3, we have m greater than 1 and x1 is less than equal to x2. So this is m is greater than 1 and left to right. Now remember, as I told you, we will use this. We will change the loop. Now we are drawing according to y. Okay, and this is delta y is 1 and y2 minus y1. So we are drawing from top to up or up to down, whatever you call it, and x change is 1 over m. Okay, and same thing we draw it. The last condition we will just change. We are checking for x1 greater than x2. Here x1 was less than x2. Now x1 is greater than x2 and m is greater than 1. Same loop, y2 minus y1, but sorry, this time we made it y1 minus y2, because x1 is greater than x2, so y1 is also greater than y2. We can say that. Okay, and we will move here. You can see that x is equal to x minus 1 and y is equal to y minus 1, and we draw this. Okay, now this is the algorithm, okay, which has 4 conditions. This seems a very big algorithm, but it is not complicated. The DD algorithm, we call it the DDA, which is digital differential analyzer algorithm. This is DD algorithm. Okay, so I will put it like this. Okay, and then like this. Okay, so this is the DDA algorithm, which is 4 conditions. That's all. And this algorithm takes 4 points. Okay, in the context we use to draw, because we will use the context here. So for every point drawing, we will use the context, and this is the end of the algorithm. Now we test this algorithm, and to test it, I have 4 canvases. Canvas 1, then canvas 2, canvas 3, and canvas 4. Why I have 4 canvases? Because I want to test them all 4 conditions at the same time. So on canvas 1, I will have the first condition, in which m is less than 1 and x1 is less than x2. Okay, so how do we know m is less than 1? We will find the value of m for canvas 1. Okay, so you can see that y2 minus y1, this is 130 minus 10, 120. Okay, and 130 minus 0, this is 130. So 120 divided by 130, this is less than 1. This is 0.9 something. Okay, so we will get 0.9 for this point, and we can change it. It's not a problem. Okay, so we call this canvas 1. Where is canvas 1? Because we have defined 4 canvases. Here, canvas 1 is 1, then I have canvas 2, then I have canvas 3 and canvas 4. So on canvas 1, I will have the first condition. On second canvas, I will have second condition, third condition, and finally, I will have 4 condition here. So on canvas 1, I take these points for this condition. x1 is less than x2. You can see 0 is less than 130. and m is less than 1. Okay, so I have this context which will give me canvas 1. What is get context? This is a function I defined and it will give me the canvas 1 context. Okay, it is the function which is at the top of the code, but it's not important. The important thing you need to understand is that here I get canvas 1. So I draw a line on canvas 1 with these 4 points. Okay, and I draw some text. What is the text? The text will actually draw the points. Okay, so it will draw that this is canvas 1 and it will draw that these are the 4 points. Okay, so my first points, remember my points are 0, 10 and 130, 130. So let's go there and see that my points. So these are my points. Okay, I have what? I have 0, 10 and 130, 130. Okay, now if I want to see the output, so on console, okay, I will see my first one, the first canvas. This is for the first one. The m is 0.92, b is 0. So this is m is less than 1. Okay, here, and b is equal to 0. Okay, then okay, uh, okay, fine. So this is my first one. The second one is this one. The point x is 130 0 and sorry, x is 130 10, and the first point, and the second point is 0 130. Okay, 130 10 and 0 130. That's my second canvas. So I will go to second canvas. Okay, 0 130 130 10, and here the m value is minus 0.92. This is less than 0. Okay, it is negative, but still it is less than 0. It can be some other value. If I want it to make it something like this, for example, even like this, okay, it was not a problem. I can move this to this point, let's say. Instead of 0 130, I can make it minus 100 and minus 10, let's say. Okay, I can make it, the second point is minus 100. Okay, and minus 10, just for testing. Okay, and when I refresh this, so it has become like this. Okay, 0 minus 10, 130 minus 100. So the second one is, oh, it's still negative. Okay, I need to move that 130 minus, oh, sorry, I should have changed that the second point. Wait. Second condition. Okay, the second point. Okay, it can be any point, no problem. Okay, but this is the second point which has less than, m is less than 1, so we get this point. Now the third condition on canvas 3. On canvas 3, I have these points. x1 is equal to 0, 30, and x2 is equal to 90, 200. Okay, so I draw these points and then I draw text. Okay, so 0, 30, 90, 200 is this point. 0, 30, 90, 200. Here m is more than 1. You can see 1.88. This is more than 1. It is going up, and at the same time we are going from left to right, 0, 30 to 90, 200. Okay, now this thing, canvas 3, and these point values, I write it using this function, draw text. So the purpose of draw text is just to write this text so that we know what are the points. Okay, finally the fourth condition is when m is greater than 1 and x1 is greater than x2. Okay, so x1 is greater than x2, it means that we are going from right to left. So my point on the right is 90, 200, and on the left is 0 minus 130. Okay, so this is 90, 200 and 0 minus 130. So I start from here and I go down, and this is my canvas 4, this is my another point, and that gives me what is m. M is 3.66. Again, this is greater than 1. but this starts from right to left. So I have 4 canvas here to tell you that even though you can define all of them on the same canvas, it's not a problem. Okay, you can define all of them on the same. Instead of changing this to canvas 4, you can make it same as canvas 1, for example. Okay, so if you make them all canvas 1, they will be on the same canvas, but it may be confusing for you. That's why I just use 4 different canvases in single page, and you can see that I have drawn 4 different lines. Okay, so this is how it works. Okay, now this was the implementation. Now we want to do it using pencil, for example, ourselves. How will we do that if you want to do it yourself? Okay, on pen paper to solve this problem. So here is an example. um, we want to draw a line with endpoints 2010 and 3018. Okay, so we have 2 points. First, we want to find the slope. Slope is what? Y2 minus y1. Okay. So x1 is 20, y1 is 10, x2 is 30, and y2 is 18. So y2 minus y1 is 18 minus 10. That gives us 18 minus 10 divided by x2 minus x1, which is 30 minus 20. So this is 8 divided by 10, and the answer is 0.8. So the slope is less than 1. Okay, positive slope less than 1, and we will use this thing, this equation, which is the condition that if slope is less than 1, okay, m is less than 1, then x is equal to xk plus 1 and y is equal to yk plus m. Okay, this is the thing we are going to use. Now, our first point is what? Our first point is 2010. What will be our next point? We will use this. So our next point, x will be increased by 1, which means 21, and y will be increased by m. So 10 plus 0.8, that will be 10.8, and 10.8 is equal to 11. So we will consider that as an 11, and we will put at 11. Okay. So the next point, you see, we have found 10.8, but that will be 11. Then we increase x by 1, that is 22, and increase y by 0.8. So 10.8 plus 0.8, that is 11.6. So 11.6, we round it off to 12. So that will be 22.12. We increase x by 1, that becomes 23. And we increase y by 0.8. So 11.6 plus 0.8, that becomes 12.4. When we round it, it again becomes 12. So this point and this point, you see they have same y. Okay, so this line will be something in which some points the y-axis will be the same. Okay. Similarly, we increase this for 13, 14, and so on. And the last point that we get is 18, 30, 18. So 30, 18 is the last point, and we will stop our loop here because we started from the first point on the left, x1, y1, and we stop at the second point, which is 30, 18. Okay, so using canvas, I have shown to you, and this is how it should look like, on let's say OpenGL. But I have shown the same thing to you in the canvas as well. Okay. Now there is the next algorithm, which is Bresenham's line drawing algorithm. Okay, and what's in this algorithm? Well, this algorithm is slightly different. Okay, it has the same thing that we have equation of line y is equal to mx plus b, but it considers something which we call is the actual point. The actual point value will be dependent on m. For example, here the actual point was 10.8, but we used 11. Okay, now we just considered it as 11 without thinking further. Okay, but here this is slightly changed, and we will see how does it work. Now there is some mathematics behind this, but I'm not going to go into this mathematics. Okay, if you want to learn it, okay, that's good, but I'm not going to ask about this in the exam. So after a few equations we solve this, and what we get at the end, we have something which we call as you see this formula p k plus 1. So we have a point, okay, which we call it as p, and this point will give us what should we do with x and y values. Okay, so what we have is that at the end we find something which is known as p0, which is the starting point from which we start. Okay, so the condition is like this. For Bresenham line drawing algorithm, what we have is that we define it for m less than 1. Okay, and similarly we can define it for m greater than 1, but just consider for the time being m less than 1. And we have n points, input n points, 2 points, x0, y0 and xn, yn. Okay, so xn, yn is the last point, x0, y0 is the first point from which we start. So from these you will calculate delta x. Delta x is the change in x, okay, which is xn minus x0, that is delta x. Delta y is yn minus y0. 2 delta y, we will multiply delta y by 2, and then we need 2 delta y minus 2 delta x. Okay, we start with a point p0, okay, and p0 is equal to 2 delta y minus delta x. How do we get this? We get this from these equations. You know, in the last pages I told you many equations. So P0 at the end we get as 2 delta y minus delta x. Okay, so that is our starting point. And then we will use this P0 in the condition. So starting from k is equal to 0 to n, that will draw n points because we have total of n points. First thing is we will check the value of pk. Okay, if pk is less than 0, then we will not, you see here, we will not increase the y, we will just increase the x by 1. Okay, and we will find the next pk using this formula, pk plus 2 delta y. If otherwise, if pk is not less than 0, then we will also change yk plus 1. Here we did not change yk, it was the same. Here we made an update to yk plus 1. Okay, which is the next point, and then we update our pk like this. Here we update pk like this. So what does that mean? We will have a starting point p0, and depending upon the value of p0, if it's less than 0 we will do something, and if it is not less than 0 we will do something else. Okay, and depending upon one or the other condition, the next value of pk will be either like this, pk plus 1 is equal to pk plus 2 delta y, or it will be like this, pk plus 1 is equal to pk plus 2 delta y minus 2 delta x. Okay, so that is how we will find it, and we will continue this until n points. Okay, so here is an example. Draw a line with the endpoints. Now this time the endpoints are the same, just like the previous example, but in previous example we used the DDA algorithm. Here we are going to use the Bresenham line drawing algorithm. So we find delta x, which is x2 minus x1, 30 minus 20. 2 delta x is 2 multiplied by 10, which is 20. Delta y is y2 minus y1. Y2 is 18, y1 is 10, so 18 minus 10 is equal to 8. This is delta y, and 2 delta y minus 2 delta x, we need it in the equation, so we will find this to be minus 4. And then we start with p0. So p0 is equal to 2 delta y minus 2 delta x. We know this is p0. Okay, 2 delta y minus delta x. So we will find this value to be 6. And first we start with the first point, which is 2010. We will plot this point. Okay, and then we will continue with the rest of the points. So from k is equal to 0, we start with k is equal to 0 to k is equal to n. N is from 0 to 9. Okay, actually 10, but we start from 0 to it will go to 9. The difference from 10 to 8, and then difference from 20 to 30 is 10 points. So from 0 to 9, these are total 10 points. Okay, first we have p0. P0 is 2 delta y minus delta x, which is 6. So here we put 6 for p0. Okay, and because the condition is that p0 is not less than x, not less than 0, p0 is not less than 0, it is greater than 0, so we'll plot this one. We will increase x and we will increase y. Now x and y was 2010. Now we will increase both of them, so that will become 2111. So here the first point is 2111. Okay, and then we need to find the value of next p, because we use this one. So how do we find p1? P1 is equal to p0 plus 2 delta y minus 2 delta x. Okay, p0 plus 2 delta y minus 2 delta x, and 2 delta y minus 2 delta x is equal to minus 4. Okay, so we will put minus 4 here in this equation. P0 minus 4, p0 was 6, 6 minus 4 is 2, so our p1 will be equal to 2, which you can see that p1 is equal to 2. Okay, and our next point, when we come here, p1 is equal to 2, which is not less than 0. We will use the same condition. We will draw the next point. So the next point is increase both x and y. Okay, and that will be after 2111, we will make it 22 and 12, and we will continue this. When we find p2, it will be minus 2. So p2 is less than 0, we will only increase x, we will not increase y. You can see here, and so on. So at the end we get the last point as 3018. Okay, that's how we do it. Okay, so this will be the drawing using Bresenham's line drawing algorithm. Okay, so with this we finish the line drawing algorithm as well. We know how to draw lines in using these two algorithms. Okay, we will take a short break of 5 minutes and then we will continue after 5 minutes. If you have any question, you can ask me. So what we have here is the circle drawing algorithm. As I explained, that line drawing is one thing, and based on line drawing we can draw triangle, we can draw square, we can draw any polygon. But circle is a special case and we have a special algorithm for circle drawing. Now when we started the line drawing algorithm, remember we had the line equation y is equal to mx plus b. Okay, and using that line equation we had two algorithms, the DDA and the Bresenham's algorithm. Similarly, for circle drawing we have algorithms and we will use the circle drawing algorithm. Okay, so we have two algorithms just like before. One algorithm is not very efficient, not very fast, okay, and the other one is fast. So we will see that the circle drawing algorithms, they start with the equation of circle, which is x square plus y square is equal to r. Okay, so x and y, they are points, any point on the circle, and r is the radius. Okay, so for a circle, all the points will be on the circle if these values they are considered as true. Okay, which means that a point x y will be on a circle with a radius r if this equation is true for that. So we can write a simple circle drawing algorithm when we find the value of y from the above. So we will take y on the left side and x square on the right side. That will become r square minus x square. Then we will take square root and it will give us y is equal to plus minus. Why is this plus minus? Because by taking we can have both the positive and the negative value after a square root is evaluated. Okay, so that will give us two possible values because y was a square. Okay, so we can have positive value of y and negative value of y, and we will see why is this thing important. Okay, now here is finding a value of y for a circle whose radius is 20. Okay, so r is equal to 20 and we will start from x is equal to 0 to, let's say, 20 points, for example. Okay, so we will start from x equal to 0, 1, 2 up to 20. So first we will put x is equal to 0 here, r will always be 20 and that will give us first y point. Then we will put x is equal to 1 here and that will give us another y point, and so on. So when we put these values one by one, you can see that when we put x is equal to 0, so that is 0 square, 20 square minus 0 square, and we take the square root of 20 square, the answer is 20. Okay. Similarly, 20 square minus 1 square root, the answer is almost 20 once again, and 20 square minus 2 square root, the answer is almost 20. So even if we are changing the value of x from 0, 1, 2, the value of y remains same. Okay, so here we can see that this x is equal to 0 here, then x is equal to 1, x is equal to 2, okay, x is equal to 3, and even x is equal to 4. Okay, so x is equal to 4, we see that we get the same y point. So x value are changing, but y value remains the same. They don't go up or they don't go down. Okay, so for the same for different values of x, we get the same value of y. When x is equal to 20, here we see, so these starting from 0 up to 20, what is the value of y? The value of y turns to be 0, which we can see here. Okay, if it is 19, what will happen? That is 20 square minus 19 square, so that gives us a value of 6. So this is the value of 6. For x is equal to 19, the value of y is 6. Now what happened to these points? These points are not there, which is now a problem. Similarly, this point is not there, this point is not there. So we cannot have a circle with those blue points. It is not a complete circle. Some points they are missing, we can see, and that creates a problem. If we remove this orange line, okay, from here, then the problem will be that these blue lines, they cannot form a good circle. Okay, so this was a simple algorithm, but this algorithm does not work. Okay, this is not a good solution. There are two reasons. One, the resulting circle has large gaps. Okay, and second, the calculations are not very efficient. Why they are not very efficient? Because in calculations we use the square root and we use the squares. Okay, so this is not very efficient algorithm. We need to design a better algorithm that can actually give us fast results. Okay, so because of these two reasons, okay, we don't use this algorithm and we need a more efficient and more accurate solution, okay, which can give us good results. Now we need to consider one property of the circle is that there is eight-way symmetry. What is eight-way symmetry? It means that for any point x and y anywhere on the circle, we will find 7 more points which are a change, for the same value of x and y, they are just changing either their signs or their position. So for example, this point xy, if you change it to minus xy, this is this point on the circle. If you change it to x minus y, you will get this point on the circle. If you change the y and x direction, that will become yx. If you change the signs of y, that will become, actually this one is, yeah, minus yx, okay, this one is minus y minus x, this one is y minus x, and so on. Okay, so at the end you see that from 1 xy, okay, we get 7 more positions, a total of 8 points, okay, with same value of x and y. Same value means that the magnitude remains the same. For example, it is 10 and 12, so x will remain 12 here, 10 here, and y will become 12. We will change that, so we can get 8 points. So what's the, and here we are talking about a circle which is centered at 0, 0. So this point is 0, 0. Why is this important? Because if we move this circle from 0, 0 to some other point, then we need to find that distance and we will add that distance to the center, okay, and we will come to that point very quickly. Okay, so just like line drawing algorithm in which we had some choices, here we have the circle drawing algorithm, and this special algorithm is known as the midpoint circle algorithm. Okay, so in the midpoint circle algorithm we have 8-way symmetry. Okay, so we calculate only one point, okay, which is the top right eighth of circle, and then use symmetry to get the rest of the points. So it means that for completing circle we need only these points, okay, from this 0 y to this position. So if we can find these points, the remaining circle can be completed automatically, which is wonderful. That's the great thing that we will do. We will need only a few calculations. Okay, so that is 1/8 of a calculation, which means about 15, less than 15, 14% of calculations, and we will do find the remaining part of the circle. Okay, so how do we do this? For the midpoint circle algorithm, just like the line drawing algorithm, assume that we have a point xk, yk. Let's say this is the first point, okay, and we want to move to the right, so x will be plus 1, but what will be the value of y? Should we draw here or should we draw here? Okay, that's the choice, and this choice we need to understand. So we will choose either this or this depending upon where this circle is close. So in this case it is close to this point, so we'll choose this point. Okay, but for the next one we will choose this point, and similarly we will choose this one. Okay, so this is the circle drawing algorithm, and we will see how does that work. Okay, so there is some calculation. Just like the line drawing algorithm, we start with the function for a circle, which is x square plus y square minus r square. Okay, and then we will have these calculations that if this is less than you see 0, okay, then the xy is inside the circle boundary. If it is equal to 0, then on the circle boundary. Okay, so this is off the circle boundary, this is in the circle boundary, and this is on the circle boundary. So we will find the value of f of xy. If it is more than 1, we will choose this point. If it is less than 1, we will choose this point. Sorry, less than 0. And if it is 0, then we will choose this point. Okay, let's say. Okay, so here is the example. So by evaluating this function at the midpoint between the candidate pixels, we can make our decision which point to choose. Okay, now we continue this calculation just like we did for the line algorithm. There are some calculations, and at the end we find that there is a decision variable p0 which is equal to 5 by 4 minus r. This is a fixed value. Remember, p0 is equal to 5 by 4 minus r, and then we need to find p1, p2, etc. for the remaining points. So our starting decision point is this, and it will decide if it is less than 0 or greater than 0. If p0 is less than 0, then we will use p1 as this. If it is greater than 0, then we will use p1 using this equation. Okay, so that will give us p1, and then we will find p2, etc. And every time we will update the value of p1, p2, etc. using less than 0 or greater than 0 condition. Okay, so how do we do this overall? We will start with p0 and we will start drawing x and y. Okay, but where do we find x and y? It will depend on the value of p0. If p0 is less than 0, we will decrease y. If it is greater than 0, we will not decrease y. Okay, so we will see that. Now here is the whole algorithm. We have a radius r and a center of the circle. Okay, so before we consider that the center is 0 0, but it may not be 0 0, then we set the coordinates for the first point on the circumference of a circle centered on the origin s. So our first point is that we will make x as 0 and we will take y as r. So what is 0 r? If I can draw it, then my circle, okay, center is at 0 0, and 0 r is the top point of the circle. That will be my first point. I will start from here and then I will move towards right. Okay, so we will calculate the initial value of the decision parameter like this: p0 is equal to 5 by 4 minus r. Okay, and then starting with k is equal to 0 at each position xk, we will perform the following test. If pk is less than 0, then the next point along the circle is xk plus 1 yk, and pk plus 1 will be this. But if it is not less than 0, then we will make it xk plus 1, yk plus 1, and our pk plus 1 will be this. Okay, this will be pk plus 1 if it is not less than 0. And from these, we will find what? The remaining symmetry points. Okay, because xk, this will be only one point. The remaining points will be by changing the sign of x and y, and by changing the position of x and y interchanging. So it will become y and x. Okay, so that will give us a total of 8 points. So we will find 8 points. Okay, and after that, when we have these 8 points, actually we will add the center, because we started with a center value of xc, yc. So we need to add the center value to this to get it. Okay, so that is how we will repeat this step, and it will be going until x is greater than or equal to y. Okay, this condition y x is greater than or equal to y, because x is going to repeat, and there will be a point when y will become less than x, so we will stop at that point. Okay, so let's see the example, and to make it simple we will center our circuit at 0 0. If it is not 0 0, we will add the value of the center at the end. Okay, but here we don't add it, we start with 0 0, and we have a radius of 10. Now remember, we need just two things. One is the center of a circle, the other one is the radius of 10. Okay, so we have the midpoint circle algorithm. It's like this. We start at 0 0. First k is 0. What is pk? What will be pk in your opinion? Any idea? What will be pk? Let me draw it, just wait. uh, okay, so I have, just give me 1 minute, I will write here. So my R is equal to 0. Okay. Okay. So I start with my R is equal to 10, not 0. And my center point is 0, 0. Okay, so 0, 0 is my center. And my first point will be 0, R, which means this is equal to 0, 10. Okay, so 0, 10 is something like here, for example, let's say. Okay, that will be my first point. And my P0, this is equal to 5 by 4 minus R. This is equal to 5 by 4 minus 10. This is equal to what? This is equal to 5 minus 40 divided by 4. This is equal to minus 35 divided by 4. Okay, so this is equal to minus 8.75. That is the value of, you see what? This is the value of P0. So P0 is equal to what? It's equal to minus 8.75 from here. I hope you understand this calculation. Why do we need P0? Because this is the first decision variable. So after P0, this is less than 0. So P0 is less than 0. So which equation we will use? If P0 is less than 0, how do we find less? We see that if P0 is less than 0, then we will use P1 as Pk plus 2xk plus 1 plus 1. Okay, but before finding this, we will have xk plus 1 yk. First we will write this xk plus 1 yk. So x will be increased, y will not be increased. X will go to right side, y will not increase. So our point will be this. Okay, now x is equal to 10. So the first point was what? The first point, if I draw it here, x and y and pk, okay, and k. So k is equal to 0. Pk was what? P0. P0 is minus 8.75. X was what? We started with x is equal to 0. What was y? Y was equal to 10, because this was our first point, 0r. So y is equal to 10. Okay, now after this algorithm we say that if P0 is less than 0, then we will use this one. So it is less than 0, we will use Pk plus 2xk plus 1. Pk plus 2xk plus 1 plus 1. So P1 is equal to P0 plus 2xk plus 1 plus 1. This is equal to what? P0 is minus 8.75. Okay, then plus 2 times xk plus 1. Okay, actually we need to draw the xk plus 1, which was this point, 1 and 10, because we don't increase the 10. So xk plus 1 is 1 plus 1. Okay, so that is 2 into 1 is 1 plus 1, 3, and minus 8.75. This is equal to minus 8.75 plus 3. This is equal to minus 5.75. Okay, so P1 is equal to minus 5.75. So I will use P1 as minus 5.75 and K is 1. So I will continue like this and I will find the remaining points. So here it is 10. Let's try one more time. Okay. For K is equal to 2, what I will do, I will consider this. This is less than 0. Okay. So if P1 is less than 0, I will again use the same equation. Okay. First, I will not change the y. So the point will be 2 and 10. I will not change the y. Here, you see. Here we don't change the y, we only change the x because it is less than 0. But we will find the new point. What is the new point? The new point will be P2, just using same equation, this is equal to P1 plus 2 xk plus 1 plus 1. Okay, this one. Okay, and this is equal to what? P1 is minus 5.75 plus 2 times x1 is 2 plus 1. This is equal to minus 5.75 and this is 4 plus 1, 5 plus 5. This is equal to minus 0.75. So that will become minus 0.75. Okay, so we can see the difference of 3 is coming here, and in this way, although it is 3 here, but the next time it will not be different. So let's try one more time. Okay, again it's less than 0. It's less than 0, so we will do the same thing. P3 will be what? So less than 0 means we will increase this, but we will not increase this. It will remain 10. Okay, and we will find P3. P3 is equal to P2 plus 2 xk plus 1 plus 1. This is equal to P2 is minus 0.75 plus 2 into xk plus 1 is 3. So this is 3 plus 1. And this is equal to minus 0.75 plus 7. Okay, this is equal to 6.25. Okay, and this is equal to 6.25. Now we have a positive value. Okay, so because we have a positive value, for the next time we will increase this by decrease this, sorry, we will decrease this. Here you can see we will decrease this y as well. So it is, and when we decrease this, we will also use the next value as this. We will have minus 2 yk plus 1 additional. Okay, so it is here. That is P4. We need to find P4. So P4 equation is different. It is P3 plus 2 xk plus 1 minus 2 yk. So this is plus 1 minus 2 yk plus 1. Okay, which means that this value will have yk plus 1 is 9. Okay, so this is equal to what? P3 is 6.25 plus 2 times xk plus 1. What is 2 times xk plus 1? This is 2 times 4, which is 8, plus then 1 minus 2 times 9. 2 times 9 is 18. Okay, so we will find some value. This is 8 plus 1, 9, 9 plus 6, 15, 15.25 minus 18. This is equal to minus 2.75. Again, this is negative. So next time it will not change, it will remain the same. 5, 9 for 5. And this is minus 2.75. And we will continue like this. So when it is positive, we will not change it. When it is negative, we will change something like that, and we will continue this. And this is what you need to fill by hand. Okay, these things we need to fill by hand to find the values of the circle. Okay. Similarly, you can have the midpoint circle algorithm to draw the circle with radius 15. Okay, so instead of 10 here, we will start with 15. So if I change the color, for example, for next circle, this will be 15, and this will be r minus 15. We will start minus, this will become 20, that will become minus 15, that will become minus 3.75. Okay, and similarly we will continue the rest, and there will be slight changes. So the first point will be 0.15 because my first point is 0r, which is 0.15. So after 15, the next will be maybe 14, and then maybe 14, 13, something like this, and this will keep increasing. Okay, so if we draw these, at the end I will get this point. So when I get this point, for the first quadrant, I will get this point, I will get also this point, I will get this point, I will get this point because of the symmetry, and for one point I will get 4. And so I need to find these points, it will give me these points, etc. And at the end I will have a complete circle from this center. Okay, that's the example for the second example. Okay, now what do we learn? I will just finish my lecture. What we learn is that 8-way symmetry can hugely reduce the work in drawing a circle. How it can reduce? Because after finding one point, the remaining 7 points can be found just by changing the sign or changing the position of x and y, and also moving in unit steps along the x-axis. At each point along the circle's edge, we need to choose between two possible y coordinates, either decrease it or not decrease it. Okay, so what we have looked in the last few lectures is the idea of converting lines, and we need to do it fast. Okay, so we draw something on the screen, we need to do it fast. So for line drawing we have either DDA or Bresenham, and for circle we have the midpoint algorithm. Okay, so this is the midpoint circle algorithm example that we choose between. You see, if this is our x point, for next x point we will make a selection between this is my midpoint, so this circle is above the midpoint, so I will choose this. In this case now it is below the midpoint, so I will choose this one. Okay, and with this I will just stop my lecture, and if you have any question you can ask me.